We're going to take a look in this video at saturated solution equilibrium, which would be KSP calculation. Now, as a reminder, remember that a saturated solution is created when the maximum amount of a solid becomes aqueous and an equilibrium exists between the solid and the aqueous states in this system. A saturated solution is created if we were to take a solid, in this case something such as silver chloride solid, and dump it into some water. We'd see solid silver chloride initially settle to the bottom of the beaker. What we're going to see occurring is some of the silver chloride is going to break apart and begin to form silver and chloride aqueous ions. Eventually, as more and more aqueous, we hit a point that's referred to as saturated. This is when we have the maximum amount of aqueous ions present in the solution. Now, once saturated, the system, where the rate at which the solid is dissolving is the same at which ions go back to being solid. Saturated, the key thing here is that the rate at which AgCl solid separates into Ag plus and Cl minus ions is the same rate that a pair of the aqueous ions would return to being solid. What this does, that equilibrium, it keeps the concentration of the Ag plus and Cl minus aqueous ions constant. For this saturated system, because it's at equilibrium, we'll use the Rice strategy. Now remember, the solid state will drop out when we set up an equilibrium system using our Rice strategy. Initially, we'll say that the amount of aqueous silver and chloride ions is going to be 0, as there's not any aqueous ions present until the solid actually begins to dissolve. With this saturated system in our Rice strategy, we're going to say that the concentration of silver ions, since we don't know what it is, it's going to go up by a quantity X as we work with our Rice strategy. Now, since the amount of chloride ion that gets created is the same as the amount of silver ions being created, they're in a 1-to-1 ratio, we can also represent the chloride concentration in the equilibrium system by X. For every ionic solid, the amount of ions that become aqueous to reach the saturation point is different. Since a saturated solution is an equilibrium system, the amount of aqueous ions present in a saturated solution can be determined by the equilibrium constant, which p-value. Now, for this particular equilibrium reaction, our KSP expression is just the concentration of the silver ions times the concentration of the chloride ions. Now, the value we put inside the brackets has to specifically be the at equilibrium concentrations, because it's only at equilibrium when this is equal to the KSP value. In this case, what we're going to use the Rice strategy, because that represents the at equilibrium constants, and that's going to be placed into our KSP setup over here for the silver concentration and the chloride concentration. Following with our math, we now have that the KSP value is equal to the quantity X squared. Solving for X, we get 1.3 times 10⁻⁵ molar, because X is equal to both the silver concentration and the chloride concentration. We now have the chloride concentrations at equilibrium in this saturated system. Saturated system, this is one for copper 1 sulfide. Now the key thing here is in this system, for every 2 copper 1+ ions that form, a single sulfide ion forms. So the ratio of sulfide ions is 2-to-1. Because if we're going to call the amount of S2, because we form 2 Cu1+ ions for every sulfide ion that forms, we then are going to refer to the amount of copper 1+ ions as 2X. Now, setting up the KSP expression for this particular equilibrium system, let's remember now, because there's a 2 in front of the copper 1+ ions in the balance equation, we get an exponent of 2 outside the bracket for the copper 1+ ion concentration at equilibrium. Now we have to remember we're going to use the concentrations of E, So our copper 1 plus concentration is 2x. So inside the bracket, we're going to place 2x for the copper 1 plus. The S2 minus concentration is x. That's going to go inside the bracket for the equilibrium concentration of the sulfide ions. Now multiplying or squaring our 2x here, 2x times 2x gives us 4x squared, and then that's going to be multiplied times the quantity x. So what we have is the KSP value of 1 times 10 to the negative 48 is equal to 4x cubed. Our first step will be to divide by 4. Once dividing by 4, our next step will be to take the cube root or raise this to the 1/3 power to solve for x. Solving for x, we get 6 times 10 to the negative 17th molar, and that will give us our sulfide concentration in the saturated equilibrium system. But since there's twice as many copper 1 plus ions as sulfide ions, the copper 1 plus ion, all the concentration we got for the sulfide, and multiply by 2, and we get the copper 1 plus 2 times 10 to the negative 16th molar.